Not going to announce me or anything? And now, the inimitable.
And now, the inimitable, fantastic, superpower-laden Guido Van Rossum.
Thank you, Jesse. Well, it seems you don't hate these events as much as I do. I'm also very, very flattered that everybody actually turned their clock forward so they would be able to attend. Now let's see how we control this computer. Thank you, Python Software Foundation. Oh my gosh, did I have some kind of automatic? Okay, we're gonna have to debug this. Does anyone know how that works?
There you go. Quick back.
Use the arrow keys, not the...
I was using arrow keys.
But just don't hit play.
Okay, don't hit play. Well, I don't know which button is play, but apparently it's the space bar. Wow, okay, well, thank you everyone for helping me out with this great technical difficulty. I wanted to show a picture that just sort of touched my heart. There's this woman in Japan, her name is Yuko Honda, and she's a bit of a geek and a bit of a geek fan and a bit of an artist. And she somehow decided that she wanted to give back to open source by drawing open source logos in her lattes. And she even sent me a little video that I'm not sure I can share. I'll have to ask her first how she makes them. She draws with like stirrers and tiny sticks, what are they called, in the latte until it is an exact copy of the logo. So she did a PSF logo at some point, and I liked that so much that I thought to show it to everyone, her wonderful artwork, and as sort of to give me the opportunity to thank the PSF for once again being sort of the force behind this amazing conference. Okay, let's see what happens if I hit an arrow key. Because I actually did prepare some kind of topic I'd like to talk about. And here we don't see this so much. Everybody here comes up to me and they say, I love Python. Python is so great. I love meta classes. Oh, I'm so glad that Python 3 is coming out. But if you go back out there in the real world, you might encounter some people who have less friendly things to say about Python. And without too much generalization, a fair number of those I consider trolls. So what exactly is a troll? You've encountered trolls before. A troll is a question that is not really meant as a question, but is just sort of trying to make you uncomfortable or start a flame war without a way out. A troll is also a person who asks questions like that. And when I see a troll, I usually just turn around and ignore them. But that you don't always have the opportunity. When someone shakes my hand and then starts trolling, then I'll have to give an answer. So I've thought about sort of a number of questions that trolls have asked and things that trolls have said about Python over the years. And I'm just going to use those as one way to sort of speak out what I think is important in Python. And at some point, I'll probably forget about the trolls, because it's really just a sort of an umbrella topic. So it used to be that one of the most common trolls you heard about Python was, oh, you can't be serious with the white space. The white space for indentation is such a stupid thing. I don't actually hear that very much anymore. The thing is, when people complained about the white space, we sort of, after a while as a community, we developed a standard answer, which was, you must not have tried it yet. There aren't too many people left left who haven't tried it yet. So I think that's why that troll has gone away. Or at least the people who still haven't tried it know people who have tried it, and so they realize, wonderful, modern technology. Or at least I still remember my password. So let's talk about some other trolls that we hear. Python sucks. In general, my language is better than Python. It could be because it has static typing or because it has an event loop. I think that is mostly all bullshit. We do the same thing. We go, oh, Python is so much cleaner than Ruby or Perl. If you really think about it, if you look at it from 10 kilometers above, Python and Ruby and Perl are exactly the same language. The languages that sort of are fundamentally different are languages like Java, which comes from a completely different tradition, has a completely different philosophy, and a completely different way of running its community too, by the way, because also if you look at the Ruby community or the Perl community, they're organized in a similar way as we are. They should be our friends. C++ is another language that is really different from Python. Lisp, on the other hand, is a language that is not all that different from Python, even though you may not notice it because it looks so different, but it actually does very many of the same things. So don't get pulled into language comparisons, and sort of be proud of your language, but don't diss another language. And don't worry that this other language, which suddenly all your friends are talking about, everybody is learning Ruby on Rails. Well, in the world as a whole, there's room for all of them, and it's not actually the case that Ruby is kicking Python's butt in any particular place. So don't worry, be happy. Look at how many people there are here who will come back next year. I don't know what we're going to do with the newbies next year because the space won't be big enough. But don't get pulled into it. Python 3. So people ask, when will you admit Python 3 was a mistake? When will we finally see a Python 2.8 release? Why don't we just add all the features that we deleted from Python 3 back so that we can write code that works in both code bases? Well, I want to take a pragmatic point of view there because we did actually add one feature back. If you saw Benjamin Peterson's lightning talk yesterday about why Python 3.3 is going to be awesome, we put Unicode literals back into Python 3 purely as a backwards compatibility hack. They have no meaning. They mean the exact same thing as regular strings. But it means that a certain style of working with code that has a single code base that works in both cases. Here we go again. I really apologize. I should have used a real presentation tool instead of Google Docs and Preview. It was very quick to produce, but it sort of the presentation mechanics are horrible. Python 3 is doing fine. I hear buzz from people everywhere who are seriously thinking about moving to Python 3. I was talking on the exhibit floor to an engineer of a company that has a lot of Python. Not only do they use Python on their servers, but they also ship an entire Python distribution to their clients. And you are all clients of that company, by the way, probably. They are considering Python 3 as just a logical next step after Python 2.7. And they can do it, and they will do it. NumPy is being ported to Python 3. More and more projects see the advantages of maintaining Python 3 port. And more knowledge becomes available about what is the best strategy or how to use each of the possible strategies for porting Python from Python 2 to Python 3. Of course, using Python 2.6 or 2.7 as a stepping stone is a very good strategy, but sort of when we started the Python 3 adventure 3.5 years ago, I thought that the intersection between the two versions of the languages would be too small to work with a single code base. People have proven me wrong. With libraries like 6 and a few tweaks like the Unicode literals, it is actually fairly reasonable to consider writing code in Python 2.6 that will also work in Python 3.3. Keep it awake. So we knew it was going to take a long time. We knew it was going to be painful. But there is light at the end of the tunnel, and as I said at some point foolishly during a panel in the web meeting before the conference, at some point we'll look back to these days and we'll realize, do you remember when we had to keep our code backwards compatibility with Python 2? That was tough. I think I said that was hell. From where you are now, it may look like hell, but from 5 years in the future, it will look like, okay, we dealt with that, we did that, we got out of it, we got over it, and now we can all use Python 3 happily ever after. That will happen. Don't worry. It will happen, and sort of better tools and techniques are being made available, and more ports of more dependencies in everybody's dependency graph will be available. So the excuse, I'm waiting for package X to be ported, will be less and less valid. Sort of. It is a game of chicken, but somebody is going to jump. Okay, let's see what's next. PyPy, another very leading question. Given that PyPy is so much faster than CPython, when will PyPy become the reference implementation? Why are you still putting all this effort in CPython? Well, how many of you are using PyPy in production? Do I see hands somewhere? How many are using CPython in production? No hands? Okay, well that's so there's still hope. PyPy is a great project. They move from milestone to milestone. Their next milestone is Python 3 compatibility. Other milestones they are working on have to do with better support for extensions. But it's really difficult to break into an ecosystem where not everybody is writing pure Python code, but where people are also writing Python extensions, depending on those extensions, wanting those extensions to run really fast, and sort of linking all kinds of crazy things together. And CPython, as Dave Beasley actually yesterday morning also argued, CPython is a great glue system that links all those diverse pieces together. If you've written something in Fortran, you can link to it from Python using a shared library and an extension. If you have a large numerical library for which for some reason you only have a binary, you can still link it with CPython. Those are sort of features that are not so much features of the language, but features of the implementation that were very carefully built into the implementation. PyPy is working on making its situation better, and I should let them speak for themselves, but people ask my opinion, and my observation is that they still have a long way to go. And speed is not everything. Yes, if you have a sort of clean, simple program that you run all the time, and you can make that program 10 times faster just by switching Python interpreters, great. But in the real world, a system is incredibly complex. And that little piece of code that will now run 10 times faster is surrounded by lots of code that does I/O, it talks to databases, it's waiting for web services. And those things don't suddenly move faster because they're all already waiting for other things to happen at the speed that they happen. And so in a large system, you won't actually see that much of a speed up. It's only some smaller parts where you see the speed up that PyPy shows in its benchmarks. I mean, that's why they're benchmarks, to show off that there is a speed up. So it's a tough job to compete with the existing 800-pound gorilla in the field, which still is CPython. I don't know what to recommend. I don't know what to say. I think PyPy needs to be tinkered with, like David was recommending. I think PyPy can improve, and it will improve. And the people working on it are incredibly smart, and they are working hard on many different things that sort of will resolve all these issues. And so at some point, somebody will find an actual real use for a PyPy application where it really matters. And it could be that if you are shipping currently a Python installation to your clients to do some particular thing in the background of their computer, that switching to PyPy, once it is possible, actually helps you tremendously and makes your system faster. It could also mean that it makes your system smaller if you don't have to ship source code and bytecode, but just the sort of compiled binaries that come out of PyPy. I see many exciting possibilities there, but I also see years and years and years of PyPy and CPython living together as alternate Python implementations that support the same language, but that sort of live in different ecosystems in different contexts. And the choice of PyPy versus CPython is not just based on do I need speed or not, but on a much more complex set of requirements where sometimes PyPy wins and sometimes CPython wins. And in the meantime, I'm going to sort of encourage the Python dev community, the core Python developers, to make CPython better and to keep CPython sort of as the reference implementation upon which other implementations may want to improve in terms of quality of implementation or speed or whatever. But CPython will still be around for everybody's use and enjoyment. Oops, I did the play thing again. Dynamic typing. A lot of people, and some people here probably, but here nobody really has brought this up much to me. But a lot of people who don't want to use Python bring up the argument that a dynamically typed language is just not safe. And they bring up things like, well, the compiler doesn't detect the simplest errors. So I have no guarantee that if my program compiles and if it starts to run, that it won't run into some crazy name error or attribute error or type error much later during some critical run. To which my answer is, I am just the clumsiest keynote speaker. You guys should not invite me back. Can someone help me with this? I messed with it. I'm sorry. All right. Well, let's try that again. Now I forgot my password. Okay, there we are again. The type checking in compilers is actually very weak. Yes, it can tell you that you shouldn't be putting an integer into a string field or something like that. But does it tell you that you're mixing inches and feet or inches and centimeters? Does it tell you that it's possible that a certain variable could be null and that you should check for that before just using it? No. If you trust your compiler to find all the bugs in your program, you have not been doing software development for very long. So, yes, there are certain errors that will only be found out at runtime. That is a part of software. It is just as possible that the error is in some other piece of code that you interact with. Programmers are human. We all make mistakes, and the mistakes are sometimes trivial, like mistyping the name of a variable, and sometimes very deep, like not understanding the physics involved in a certain process or the mathematics involved in a certain operation. So the only way to come up with software that isn't going to fail after running for 4 hours seemingly successfully is to test it and test it again and think about it and audit it and hire smart people and hire people who know that they're not as smart as they could be, so they're not too cocky. Because if you hire someone who thinks they're incredibly smart, they may believe that they don't need to test. So work with a team with different capabilities. Work together. Help each other. Look at your code, think about your code. How can I make this better? And don't get focused on this very narrow set of things that a type checking compiler can find. And instead look at sort of errors in your code as a much wider problem that collectively nobody in software engineering has solved, no matter what they tell you. The people who do formal proof of correctness know that they're also not actually proving anything relevant to practical software development. I know my operating system kernel will never be proven correct. So I really don't understand why people are so hung up about that one thing of dynamic typing. It is incredibly important and useful in many ways. Another observation is that in a large program written in a statically typed language, at some point they invent a sublanguage or a subsystem that is effectively dynamically typed, where they have some class that has a bunch of properties, and there are ways of subclassing that class or defining other instances or classes, and it's all done through string manipulation in the language. And so now the compiler that does the type checking sees that you're passing a string here and you're getting a string back, and that's really all you're doing. And you have these coupled very generic methods and a whole bunch of objects. And underneath, you've built a whole interpreted language that is customized for some particular problem where a dynamic language was actually a better solution. So why not write the thing using an actual dynamic language in the first place, so you don't have to put so many string quotes around your identifiers? So anyway, I'm not saying that there's no room for static typing. I am saying that dynamic typing is not something that sort of is inherently inferior to static typing. One of the interesting developments recently is actually that you'll see people from the static typing camp try to design languages that sort of meet the dynamic typing population halfway. Statically typed languages that start growing little corners of the language where they're not so statically typed. Invoke dynamic in the JVM, the dynamic type in C#, optional typing in the Dart language that was developed by a bunch of Googlers. I find it an interesting development that dynamic type languages have apparently become so mature and popular that the statically typed language proponents are feeling a little uncomfortable and are designing new languages just to reel all you in and sort of see if you can become customers of their new languages, because that they're now also offering dynamic features. So watch out for that. Use the original. Okay, speed. Yeah, this is something like everybody seems to have a different opinion. Some people still reject Python outright because it is too slow. And they seem to have some proof of that I'm not aware of. Because every time I try to write something in Python, it's fast enough. And I know a lot of you have that experience too. And many other languages where execution is not too slow, development is too slow, so that's one reason why you all use dynamic languages. Mercurial, all written in Python. Blindingly fast distributed version control system, my favorite. Nobody would consider rewriting that in another language because it's not fast enough, because it is absolutely fast enough. I've heard of Java programs being replaced by Python programs. Nobody cared that the Java was supposedly to run so much faster. If you don't do it right, it won't actually make a difference. Another question I get a lot from newbie circles is, Python is so slow, but couldn't you just write a compiler that compiles it instead of interpreting it, and then the compiled code would automatically be faster? Well, that is an interesting research project that some very smart people are still working at. Turns out it's not so easy to write a compiler that maintains all the nice dynamic typing properties and also maintains semantic correctness of your program so that it actually does the same thing no matter what kind of weirdness you do somewhere under the covers, and actually runs any faster. I expect that at some point, when computers are faster, global type analysis, global static analysis of Python programs will be realistic. One way that we might see that is that you could put an annotation at the top of your module that says, there are certain insanely dynamic, crazy semantics that Python makes possible that I promise I will not try to use inside this module. Then, here we go again. Then a static type analyzer can sort of make a bunch of assumptions and do a much better job at analyzing that code and maybe optimizing it or translating it to a more statically typed language. The R-Python folks, the PyPy folks with their R-Python language are doing some of that, except they're not really declaring that this static analysis is possible. They're just sort of doing it, and if it fails, they say it wasn't R-Python. I think that a better approach for real-world, regular Python programs would be do a static analysis with some assumptions that certain crazy things like modifying the dict of globals behind your back, or modifying the dict of a class or an instance behind your back. With those assumptions, and maybe knowing what is in other modules, you have to pretty much know all the modules that are part of the program before you can do a decent job of analysis. Such analysis currently takes a long time, not something you would want to wait for if you're just running a script. So it's not very practical yet. The only time it might be practical is if you sort of want to compile a large Python program and then ship it off to a whole bunch of servers where it's going to run. We're not quite there yet where we have technology like that, but I think technology like that is possible without great compromises or changes to the Python language. Maybe we'll have to sort of be able to make assumptions like nobody is going to redefine the built-in functions to mean the opposite of what they currently mean. Where the code says true and the compiler can tell that it's not a global but the built-in true, we know that true is true and not false. Little assumptions like that, I think, will help static analysis quite a bit. So I'm hoping that there are some people with some extra brain cells that are feeling kind of antsy, who think that static analysis is an interesting project, and I hope that maybe next year we'll see presentations about this. And I will always entertain small changes to the language if it's really clear that one particular feature gets in the way of static analysis. Then we might want to have a way of turning that feature off selectively in cases where you care about static analysis. And in other cases where you're happy with the dynamic language, where you're using it more sort of exploratorily or experimentally or as a scripting language, you can still go carry out all the crazy hacks that you like. But we all know that too many crazy hacks in one program leads to unmaintainable code. Okay, another favorite object of attackers is the GIL. The GIL has been sort of, it has become everybody's scary beast, it seems. And parents warn their children, don't use Python because of the GIL. I recently answered a question from a user who was fetching the content of 2 different URLs in 2 different threads. And he was worried that those 2 URL fetches wouldn't overlap because of the GIL. The GIL said 1 thread at a time could run, so he thought that only 1 thread at a time could be engaged in I/O across the internet. That made me so sad that the GIL has become this completely out of proportion caricature of what it really is, which is a little hack to make the common case of interaction between Python code and C code much faster and cleaner and safer. And well, because of this, some people say we don't have real threads, which I would thoroughly disagree with. Python has totally real threads, and if you use them for what threads were originally meant for, OS-level threads are meant for doing parallel I/O, not for doing parallel computation. It's just sort of easier to not make that distinction to complete and allow some parallel computation, but traditionally parallel computation meant that the computation with the CPU would just sort of do a bunch of work for this thread and a bunch of work for that thread. Never again. But that sort of, if you really want to run something on lots of CPUs, you're going to have a different architecture. There are people who are running Python on machines with 64,000 CPUs. Ironically, their problem is not that the GIL, because of course they don't have the GIL because it's a separate process on each core. Their problem is some locking in their file system because these happen to be diskless computers. So they have a distributed file system, and the distributed file system didn't deal well with the default module lookup approach in Python. The bug was in their file system, not in Python. So I think that Python is a totally fine language for a multi-core computer. There are a number of very simple strategies for dealing with that. Message passing between multiple processes, for example, using the multiprocessing module, or some other approach of sharding request handling between multiple CPUs is just fine. And don't get so hung up on this GIL, and don't believe it when people say, "Oh, but Dave Beasley found a counter argument. He found a counter example where only 2 threads and only writing 1,000 bytes, it was 1,000,000 times slower." Yes, but you have to be David Beasley to be able to come up with that counter example. So what else? A related topic. Asynchronous I/O, concurrency, stackless, event loop, G-event, all kinds of very interesting alternate primitives for dealing with concurrency. I love the problem. I don't have a good solution. I'm going to say, well, that if a troll attacks me over this, I have a specific answer for each of the questions, but I don't have a real answer for what is your strategy going forward about asynchronous events. Unfortunately, for the asynchronous events, I live in this bubble where I don't have to deal with them in the way that many of you are trying to deal with them. It seems to me that G-event and things based on G-event are very interesting and useful tools. I am hesitant to add them to the standard library at this point because they're probably better off being maintained by a third party. Stackless, again, is something that would have to be part of the language definition, which I think would make the implementers of some other versions of Python like Jython and IronPython and possibly PyPy, although I don't know what their position would be. But it would make other implementations of Python much more complicated or even impossible. An event loop, depending on what your daily job is or what your code is doing, an event loop may or may not be useful. I mean, some people come to me and say, everything I do involves an event loop. Why is there no standard event loop in Python? Well, because not everything that everybody does involves an event loop. You can make an event loop the primary mechanism for synchronization in your language. And you can probably get away with that, but it is a point of philosophy in language design. It is not just something that you add on and then all your problems are solved. You can do things with an event loop in certain ways that are sometimes advantageous and sometimes make no sense. I'm personally not a fan of anything that requires me to write a so-called callback function. Whenever I see a callback, I know that I'm going to get it wrong. So I like other approaches. So in that sense, I would probably prefer the library packages that are built on top of G-event, if I understand the architecture correctly, that let you write synchronous looking code that under the hood does something asynchronously without invoking operating system threads. But I think that there are different approaches to this, and I think it's too soon to sort of pick a winner and say we're going to put that in the standard library, we're going to integrate that in the language, and this is how everybody is going to have to do it from now on. Because I know there are many different approaches. And I think sort of advanced synchronization primitives like channels or message passing or actors keep being brought up. All those things are interesting and deserve more attention. And again, if you have some spare cycles, look into them, learn about them, see if you can integrate them in Python, see if you can design a variant of Python that integrates those things. But sort of, we'll have to have a whole bunch of draft designs like that and be able to compare them before we'll actually have a good idea of what we should really do with Python 4, say if we want to make Python 4 the new target language for that solves the concurrent programming synchronization problem. So think about it. It's definitely an interesting problem. I don't have a solution myself at the moment. Oh yeah, here's an old question. Why don't you put Python in the browser? It would be so much better than JavaScript. Yes, and you couldn't get anyone to use it until all browsers supported it. And the browsers won't support it because there's nobody asking for it, because nobody would want to use it. Introducing a new language to replace JavaScript is just such an incredibly hard political problem. The biggest browser vendors in the world have not been able to solve that. They've sort of all listened to me and said, sorry, we're going to stick with JavaScript because that's the only thing that has a chance of moving forward. So don't ask me to lean on any browser vendors I might know. And it's similar for mobile. Why aren't we all programming our phones in Android, so in Python, or at least the Android phones? Well, I wish I could. If it was possible, I would probably write some Android programs occasionally, which so far I have not tried to do. I did at some point get involved with some other Googlers who were trying to make just this possible. And we were told that it was strategically not important, and we were asked not to work on it anymore. What I learned then was that there is absolutely nothing technologically stopping anyone else from doing this. There are enough tools that, given just the public documentation for how Android works and how to interface to it, and things like there is a native development kit that game developers like to use so that they can write their games in C++ or whatever they use, machine language for all I care, that lets you run arbitrary programs, and so you can just link a Python binary in with your application, and then the trick becomes taking some kind of formal description of the entire API and compiling it into a set of Python classes that interface to the real API. And I'm sure it can be done. And I hope someone else will do it, because I'm not going to be able to do it. Oh yeah, functional programming. I love functional programming languages. I don't think that Python is a functional programming language. Despite having lambda and map and filter, that doesn't make a language a functional programming language. It's an old argument. I really don't want to get into the reduce thing that was answered years ago, but it still comes up. Every once in a while, I get an email in my inbox from some random Python user who is very upset that I killed reduce, or sort of passive-aggressive comments in a G++ post about Python, where someone just out of the blue says, we want reduce back. It seems so misguided. Python is not a functional language for a very good reason. Python is very pragmatic. It lets you mess around with state. It lets you fiddle with the operating system. There are all kinds of things that you can very easily do in Python that somehow are incredibly hard in a beautiful language like Haskell. Haskell is great when you you follow all the examples. You see all these incredibly beautiful little diamonds of code that functionally translate one piece of data into another piece of data. But when you try to actually accomplish something like copy a file system or write a web server, all the messy code becomes much messier. And there isn't an easy sort of clean functional part in there that where the functional language helps you so much. What you can do is learn a functional language, get excited about some of the functional features, some of the functional ideas, and when you're writing Python, when you see an opportunity for writing something in a functional style, use a functional style. Don't get hung up about doing everything in a functional style or doing everything with higher order functions. Or emulating. I mean, you could go overboard and add a whole bunch of new built-ins or new utility functions that emulate all the Haskell utility functions, and then write lambdas and glue it all together. And you can say, wow, I can write Haskell in Python. And it will probably run incredibly slow because it's not actually a functional language, and it's still interpreted in the way that Python does it. On the other hand, if you have a problem, and some part of the problem involves taking a bunch of data and doing something with it, it can sometimes be very useful to think about that. Oh yeah, how would I do this in Haskell? Oh yeah, I can sort of create the same program structure in Python. And so you can use some functional conventions in some part of your program just fine. And then when it comes to actually writing the data to the file system or copying the directory tree or invoking a compiler or anything like that, you don't have to worry about, oh, but how do I do that in a functional style? Because that's not a particularly functional operation, and so you just use it in an imperative or an object-oriented style. So I like functional programming as a challenge and as a sort of a fresh idea, and I think it will inform some future features of some future languages. I don't expect that 30 years from now we'll all be writing purely functional code all the time. It's not just the only solution we need. Okay, the standard library. There are still people who believe that their particular clever bit of code has not had sufficient respect until it's been included in the standard library as a standard module. Don't do that. Don't worry about that. You're much better off not being in the standard library. Once you're in the standard library, you are stuck with the release schedule. If you made a mistake in your API design, you can never fix it. You're stuck with a broken API forever for backwards compatibility reasons. Essentially forever. If you have a cool idea for a new feature, you'll have to wait a year and a half or 2 years before you can put it in the next Python version. And of course, then you have to convince all your users to upgrade to that next Python version before they can benefit from the new feature. On the other hand, if you develop your clever bit of code as a third-party package and you distribute it through PyPI, there's nothing stopping you from releasing a new version every day or every week. Or you can be more systematic about it and have sort of a development team and releases, and you can do new releases every few months, and you can do alphas and betas in between. But you can adjust your development schedule to sort of the speed of the world around you. If you're hacking on something new, you probably are going to throw all of it away after sort of writing the first prototype and playing with it for a day or a week. If you've got an established project, maybe Django, you're going to be very conservative in deleting old features, except when it comes to security, I hope. But you're going to still aggressively add new functionality. And if you own your own release cycle, you can add new functionality every time you do a new release. Every month if you want to. As long as you have active users and sort of active developers, it's unlikely that your users will want to sort of stick with the same functionality for 2 years. And every new feature idea will just go in the tracker, and yeah, we can add that in the next release, which is in 2014. There are very few situations where that sort of is an acceptable development approach. Now, so what are good things to put in a standard library? It's things that enable everything else. Decorators with statements. Well, okay, they're language features, but there are things in the standard library that sort of support everything. If we had a new context manager that would sort of help you solve a certain problem, that context manager sounds like a context manager that's sort of, not a context manager that sort of deals with web requests and the SSL security or whatever. That would be something that was third party. But if you had a context manager that solved some problem where if I have two classes that want to cooperate, I want them to interact in a certain way, that's the kind of thing that goes in the standard library. We have things go in the standard library. One example is an IP address parsing and manipulation library. That was actually a pretty contentious API design. But in the end, once we settled on agreement on a particular API, the format of an IP address is not going to change again after IPv6. So as long as you support IPv4 and IPv6, that's a good module to have in the standard library because it's write once and then the functionality is there and it's usable for everyone. There's no point in different people having to reinvent that wheel over and over. But there are many areas where if you look at how often new features make sense and sort of are suggested, you really don't want to tie yourself to the development cycle of the standard library. Let's see, I have no idea where we are time-wise. Okay. Well, garbage collection. I believe that there is nothing wrong in principle with reference counting. Python has gotten a long way with reference counting. We also have some other garbage collector. So Python actually does have garbage collection, although many people don't realize that still. Yes, there are better ways of doing this, and PyPy is probably the place to experiment with better memory allocators. I am personally quite happy with how fast CPython's memory allocator works. So I would really think that this is not a very interesting topic. And my computer seems to disagree. But it does come up. And just sort of remember that Python does have garbage collection, and that first of all, reference counting is garbage collection. It is a legitimate algorithm for garbage collection. And second of all, Python doesn't have pure reference counting, but it also has a garbage collector that resolves cycles and does all sorts of clever things. What else is there? Yeah, this is more sort of a note on you can't please everyone, because all the people on my left are asking me to please stop changing the language because it's already perfect. Paul Everett famously said that about Python 1.5.2. Hi, Paul. And on my right are all the people who still have a favorite language feature that they want added. Now, the scary thing is that it's actually often the same people who walk from left to the right and back, because they don't want the language to change except for their one pet peeve. So this is never going to be resolved completely satisfactorily for everyone. My idea is that as your user base grows, you become more conservative in changes. And so there are still way more Java users than Python users, and so indeed, the Java process for getting new changes into the language and into the standard APIs is more heavyweight than Python's process. They take even longer to make changes at that level. The ultimate slow-moving language is probably C++, which has the most users. And so nobody wants it to change, but there are still people who want it to change. So they can do a new version of the language every decade, rounded up to a little more than that. Python is not quite there yet, but we do have to be very careful and not change too much at a time. And we already went through a pretty dramatic change with Python 3, of course. So let's all set our expectations low about new features landing into the language. And if you watched Benjamin's presentation last night, there are some interesting new things. And sometimes if we can do something really clever by permuting a couple of existing keywords, we can do that. But otherwise, even if you have an incredibly important use case for a new statement or expression, the hopes of getting that accepted into the language are not very high. And I know that some people sort of accept this and they define their own superset or subset of Python, and they write their own parser, and maybe they have a transformational engine that takes a program in their language which resembles Python, and then translates it into standard Python, and then runs it. And there are a couple of nice advantages to that approach. So I want to sort of give you that idea for consideration. If you really have a desperate need for certain extensions to the language that you cannot do by just importing more modules and adding more classes or functions or methods or constants. If you really want something more than that, you think you have to change the language, define your own transformation. There are clever things called import hooks that will actually let you do the transformation more or less transparently. There are downsides too, and you paint yourself into a corner where nobody else is compatible with your language, so you have to sort of have a well-defined community of users who can all use your tool. But it is possible to experiment with those kind of things, and I'm looking forward to seeing some of those things happen. Okay, well, I don't know how much time is being scheduled for audience questions, but there are 2 mics, and until the AV people or Jesse tell me to stop, I'll take questions.
Like 5 minutes for questions.
Jesse, give me 5 minutes. Anyone? Okay, well, that's fine. I see I've scared you all. Thank you.